Hi folks, so this question here comes from the Leaving Cert DCG mock paper 2026. It's actually from the ExamCraft selection of papers. So what we have here, it says B2, the image on the right shows a scaled model of a modern sculpture with intersecting surfaces. It's kind of hard to see from the image there, but you can see this little sculpture inside here. The 3D graphic below shows two of these surfaces, ABE and ABCD, and you can see the two surfaces. We've got one in pink and one in green. ABE in pink and then ABCD in green. The horizontal and vertical coordinates for the surfaces ABE and ABCD are given below. So we've got all the coordinates here. Part A, draw the elevation and plan of these planes. So anytime we're doing one of these questions, essentially what we have is coordinates X, Y and Z. So we have the X coordinate, the Y coordinate and the Z coordinate. Now when you're doing these, essentially what it is this is the measurement in, this is the measurement up, and this is the measurement down. So now that we've done that, what we're going to do is we're going to start plotting these coordinates. So usually what I do on my page is kind of base it off the tallest one here, and I'll say 95. So I'm going to keep my XY line just above the middle of the page there, and I'm going to draw a line from the left hand side. These questions are usually designed so that they fit on an A3 page. And what I'm going to do is I'm going to put in all my X coordinates in one go. Okay, so starting, pick a start point, I'm going to say about here. I'm going to read every measurement off that point there. So put the 0 on that. And I'm going to plot all my X coordinates in one go. So my X coordinates are 135, 110, 60, 105 and then 55. So there's all my X coordinates done. Okay, now I'm going to put in my Y coordinates. Okay, so from the 135, which is the longest one, and sometimes what I like to do is based on these numbers here, whichever one is the lowest number I'll put as number 1, next lowest number is number 2, next lowest number is number 3, then number 4 and number 5. So now what I'm going to do is I'll actually start with number 1. I'm going to go up 80 and down 85. So just switch out my set square here. So from the very first one, I'm going to go up 80 and down 85. So down 85, so do a line down and up 80 and get me to there. Little mark there, and down 85, mark there. So that's number 1 done. Number 2, it's going to be up 25, down 35. So up 25 and down 35. So just using maths there to work it out. So there's my two little marks. And what I will do here is get a nice little fine liner. So the very first one was for E. So this is the elevation of E. This is the plan of E down here, right there in that little dot. The next one was letter C. Okay. Now, next one we're going to do, number 3, is up 10 and down 95. So from the third one in, up 10, down 95. So I often just put the 95 on it and then I use the maths then to help me out. So up 10 will get me to there. Down 95 gets me to there. Once again, let's plot that in. Dot, little dot, and that's number 3, which is D and D. Okay, number 4, so it's up 95, down 15. Up 95, so from the 10, up 95, down 15. And that is B, and there's B, and finally then up 50, down 85. So 85, down and up 50. So 10, 20, 30, 40. 50. 85 plus 50, 135. Okay, there's our points, and there's A. So there I have A as well. Now, with the points plotted, we want to draw in our surfaces, A, B, E, and A, B, C, D. So, A to B to E. And then we've got A, B, C, D as well. So that's the elevation, same concept here. Here's the plan. And what's nice here is they do give us the graphic. So A, B, to C, to D, and back to A. And what's nice about it is when they do give you the graphic, you can kind of see that the top surface ABE is over it. So I'm going to heavy in ABE in the plan. So now that I've got ABE heavied in plan, I'll heavy in ABCD as well. But the thing is, because the surface ABE is over the surface ABCD, I'll see this, but then inside here that'll be hidden detail. Okay. So there we have the plan view of our planes. Okay, that's just my XY line. And now I'm going to draw in the elevation as well. And looking at the elevation here, once again, ABE, I can fully see it. You can kind of see from the graphic here, if you're looking in this direction here, I can see that the edge from B to C is the one that's kind of hidden behind the face. So I'll heavy in that there. Okay. This one here, heavy it as far as there. Hidden detail. And there we go. So there is the elevation done. Draw the elevation of the planes ABE and ABCD. Now, part B of the question, it tells you, determine the dihedral angle between the planes ABE and ABCD. Anytime we're getting the dihedral angle, what we have to do is we have to identify the line of intersection. So, what I'm going to do here is I'm going to colour in my planes in two colours. Okay. Now I'm going to go one with a green. Okay, so I'll do the large one, excuse me there, in green. Now fast forward the video as you need to. Now I don't have a purple, so I'm just going to use a yellow. So there's my plane ABCD, but because I can't see the full surface of it because the other one's in the way of it, I've obviously not coloured in that. Same thing down here, ABCD is going to be coloured in. You can see it there. And there we go. So there is the green surface, and now I'm going to use a yellow, ABE, the other surface. Now, as I said, skip forward in the video as you need to. It's just going to help with a little bit of visualization. So there we go. And then this surface. So I'll colour it in. Okay, so there is the elevation plan of my two surfaces. Now, once again, I've just used the yellow instead of the purple here. Now, what we have to do is we have to identify the line of intersection. The common line between the two surfaces is the line AB. So what I have to do is I have to get the line of intersection as a true length. Now first of all, have I got it as a true length so far? No, I don't, because the line AB in elevation and plan is not horizontal with the XY line, okay, in either view. So what I'm going to do is I'm going to take an auxiliary view looking at the line from the plan. So if I project from the plan, I'm going to take my heights from the elevation. So I'm going to set up an X1, Y1 parallel to that line there, which is the line there. I'm going to call that my X1, Y1. This guy up here was my XY line. Okay, now I'm going to project out perpendicular. So all the points now are going to project out perpendicular. So A goes out, D goes out, E up here to C and B as well. And there we go. Now, they've gone out. Rule of thumb here, if you project from the plan, you take your heights from the elevation. So, I'm going to take all my heights from the XY line up. So if I wanted to find, let's start with A. I'll take the distance from the XY line up to A. Find where A is here. Follow it out. Mark A. Now I'm going to go to B. That's the height for B. Follow B out. And you can see here I just need to extend my line a little bit further. Okay, and while I'm at it, I'll label that point there as A1. This guy is going to be B1. Okay, now that's the line AB. Now I want to find the other points. I'm going to start with C next. Take the distance for C. Follow it out. Let's take the distance for D. It's quite small, it's 10. You could either take the distance with your compass or you could just measure up 10 as well. There's D, and finally the last one, E. Now, what we're going to do is we're going to get the triangles once again, but this time the line AB, which is the line of intersection, will be seen as a true length because we took a view looking perpendicular to it. So, there we have E1, D1 right there, and C1 here. Now, same concept. A connects to B. That's my line of intersection, but this time that line is going to be a true length. So there is my surface ABE. Now I'm going to draw in my surface ABCD. And just put it in heavy now. So that's the line from C to D, D back to A, C to B. That's the important line there. Okay, and there's my two surfaces. Okay, don't worry about that line cutting through it there, that's just my XY line. Now, once again, what I'm going to do, I'm just going to write in a little note here. On this line, the line from A1 to B1, this is the true length of my line of intersection. So I found the true length of the line of intersection. Once again, just going to colour in my surfaces. So I went with green here for A, B, C, D. So once again, just fast forward while I'm doing the colouring here. Just helps us with the visualization. Okay, so there's the true length of my line of intersection. And there's my other surface coloured in. Okay? Excuse me. So, what we have here now, is we have the two surfaces once again. This is technically an auxiliary elevation because I projected from the plan, but I took the heights from the elevation. But more importantly, I've got my line of intersection as a true length. Now, rule of thumb here, okay, common graphical principle. If you look along a true length line and that true length line happens to be on any surface, well, whatever surface that true length line is on, when you look along the true length, you will see a true length as a point view. So if you look along a true length like a pencil here and you look along it, you'll see it as a point. When you look along it and see it as a point, any line that that surface is on, or any surface that that line is on, will then be seen as an edge. And in this case, we'll get the edge view of two surfaces, which will give us the dihedral angle. So I'm going to project out, and I'm taking a view, looking in this direction now, looking along the line. So you can see my line AB there. I'm going to project it out. I'm going to project out E as well. I'm going to project out D. And finally C. If my visualizer will let me. There we go. And then I'm going to set up an x2, y2 perpendicular. So that there is my x2, y2. Now, where do we take the measurements from here? All we do is we take our measurements from the previous xy line back, which is the distance from the x1, y1 back to here. So I'm going to take the shortest distance first, which is the distance from the x1, y1 back to A, and you'll see that that is the same distance as the x1, y1 back to B. Now the lead is a little bit blunt here, so just got to make sure I have the... There we go. So now A and B, because they're both projected out along the same line, A and B will now be seen in the same position. So that point right there is a point view of the line of intersection. So that is now A2, comma, B2. And we see the line as a point. Now the other points I'm going to project out are C, and find it out here. I'm going to do the same for D. This one. D will be out here. And finally E. And I hope my accuracy checks out here now. Now the only line I need to extend is the line for E. You can see that there. Now, if I was to label those, well, that's going to be E2. This point here is D2. And I have C2. Now what should end up happening here is I should see the surfaces ABCD and ABE as lines. So I'll check this one first. We'll see what my accuracy is like. Not bad, probably a half a mil out. That's okay. And next thing I'll do this one as well. There we go. There is my two surfaces ABCD, seen as an edge view over here, seen it as a line. And then ABE over here, which I see as another line. And more importantly, the angle between them is our dihedral angle. But remember, ABE was in yellow, so just identify it now. That's our yellow surface. And then our green surface, ABCD. And there we go. So there's the two surfaces as lines, but more importantly, we can see the dihedral angle between them. So that angle inside there is our dihedral angle. Now, the only thing I would do on the day of an exam, you should measure it. So I will actually measure it now, just for the purpose of this video. Make sure I'm accurate there in my measurement. Now the angle I'm getting there currently is 56 degrees. That's the angle that I'm getting there in between. Okay, so that's the part B of the question done there, guys. Now, part C. They'll often do this after the dihedral angle. They might ask you to get the true shape of the surface. So what they've asked us to find here now is the true shape of the surface ABE. Okay, now the easiest way to do that is actually when you see the surface ABE as an edge view. Now there's two ways I could actually do it here. I could either take this surface here, rabat it down, and then bring it down here and bring it out, or I could take an auxiliary. And that's the view, that's the one I'm actually going to do here. I'm going to do an auxiliary view, okay? And then I'll show the other methods. So, because we see the surface ABE as an edge view here, if we take a view looking perpendicular to it, if we take a view and looking perpendicular to any edge view, we will then see the true shape of that surface. So what I'm going to do now is I'm going to project out ABE like this. I'm going to take a view projecting out, looking perpendicular to it. So it's like I'm taking a view looking in this direction. You can see the arrow there, looking perpendicular to it. I'm just going to rotate my set square. Project out E as well. And there we go. Slide it back there. And then all I'm going to do is set up. I'll do my auxiliary view out here actually. Out here is what I'll do. And that there is going to be technically an X3, Y3. A third auxiliary. Now, normal rules apply here. Where do I take my measurements from? I take them from the previous XY line back. Now all I'm doing here is extending out the lines. Okay, so where do I take my measurements from? The previous XY line back. So if I want to find A, take from the X2, Y2 back to A. Follow A out, mark A. Now I'll take the distance to B, with a small distance there. Mark the distance out, B is on the same line, mark it out. And now take the distance to E. Take the distance, mark it out. And technically, what I've found here now is A3, B3, E3. And once again, I'll just maybe it in straight away this time without drawing it with the pencil. This is my surface. ABE, but more importantly, true shape. Of ABE. And there we go. Once again, probably should colour in that in yellow. All I'm going to do this time though, instead of actually colouring in the whole surface and just as a little bit of a time saver, I'll just outline it. Just showing you that that there once again is the yellow surface. And there we go. That was the true shape of our surface. Now, the other way we could have done that is, we could have done this thing called a rebatment method. So, if I just extend out my X2, Y2 there just a little bit, and then if I come to A and B, A2, B2 here, and I treat it like a hinge. So this is another method I could have done. I could have also rotated, because the surface is like an edge view here, I could have treated AB as a hinge line and rotated E like that. You can see how I've rotated E. That's one method we could do. And I've rotated it until it comes down here at this point. It's like I've taken E and I've moved it into a new position here. Now, what would I do? A and B in the previous view will stay in the same position because we know that line is a true length. Okay? But A and B have stayed in the same position. I haven't moved it. The only point I've moved is E. So what I'm going to do is I'm going to rotate E, which I did, but I have to work it back to the previous view. So I'll bring it back now. And the new position of E, it's not here anymore, it's going to be somewhere out here. How do I find it? I would have to go perpendicular to this line here, which is technically parallel with the X2, Y2. Now what I've essentially done there is a rebatment. That rotation arc will be seen as a line here. It's like I've rotated it. Remember, E rotated from its high position until it got to here. And that would be another way of getting the true shape. And the true shape then would go from here to here. I'll just put that in once again. That's just another way of finding our true shape. So lots of people might like the auxiliary if they understand that method, and lots of teachers teach that way. You hopefully would have learnt about rebatments in the oblique plane chapter. And that's what we did there. I'm just going to write that in again. True shape, ABE. So that's another method of getting the same answer for part C there. Okay, now that's part C done in two ways. Final part, determine the horizontal and vertical traces of the plane containing the surface ABCD. Okay, so what we want to do is we want to find where ABCD is sitting on an oblique plane. Now the easiest way to do that is by extending the edges. AD, if that extended down to the ground and continued on, at some point it would hit the ground down here. That's going to be a point on the oblique plane, but more importantly, because it's on the horizontal plane, that's going to be a point on the horizontal trace. If I also extend BC, at a point there it will also hit the horizontal plane, which will be a point on the horizontal trace, and when I have 2 points, I can draw in my HT. So that's the little principle that we're doing there. So they're the edges that I'm going to extend. So, how do we show that in our orthographic drawing? Well, really simple. If we extend the edge AD until it goes down and hits the XY line, okay, technically the XY line represents the ground. So that's actually, that point right there is actually this point when it hits the horizontal plane. But how do I find it in the plan? Okay, so I just follow the same rules. AD will also extend in plan, but how do I find the exact position? Well, what's great is I'll have it exactly as it hits the XY line here. So if I was to bring that down, right there in that position, that is a point on my horizontal trace. All I did was I extended the edge AD down, and I have to extend it in the plan as well. So that's one point on my horizontal trace. I want to find the second one, and the easiest one to use here is the line BC. So there's the line BC, hits the XY line there. I'm going to extend it out here in the plan as well. And then bring that down, and there we go. I now have a second point on my horizontal trace. So now that I have 2 points on the horizontal trace, I can draw it in. A little bit lighter in there. So that there is my HT, horizontal trace. Now once you have the horizontal trace, you can use any point then to find a point on the vertical trace. So I'm just going to use point B. Actually, I'm going to use A. So if you go parallel to the horizontal trace, technically what we're doing here is what's known as a horizontal cut. But if you go parallel to the horizontal trace, through A in the plan, you can see here where it hits the XY line. I'm now going to go up, and then, need to go a little bit further, then bring A across to meet it. At that point there, see here, parallel, parallel, I went up, and where A went across, that now is a point on my vertical trace. And now that I have the vertical trace, we can draw it in. Nice little question. A little bit lighter. Okay, and there we have it. That is our vertical trace. Part number 4 of the question done. So there you have it, folks. That there is the intersecting planes question from the ExamCraft mock from 2026. Nice little question, just your elevation plan, getting a dihedral angle and a true shape, and then afterwards then being able to find our vertical and horizontal traces, which are kind of lines going like that. Okay, there you have it, folks. I hope you found that helpful. That's the question done.